So Carbon Z, as a data center, has to provide services for every single bath. There's Submer, there's GRC, there's Midas, there's Delta, there's Asperitas, there's Isotope. There's lots and lots and lots of different bath manufacturers. Now, they all have the nuances, and we offer the core services for every single one. So we are not tied for a bath solution. But I am interested whether or not the oils, and also for the chips, are you guys tied or are you agnostic like we are?
So from an Intel point of view, we are agnostic to all solutions. We will work with any equipment manufacturer that approaches us that wants to have a discussion about it. From our focus is our silicon to ensure that it's viable and functional across any operational range and across the more common coolants. So we will specify certain coolants. We'll specify certain. We'll have a specification that means our equipment or our design will work optimally in XYZ thermal envelope, XYZ flow rate potentially, depending on the environment we have. But we are agnostic on the coolants. We're agnostic on the immersion tank product itself. But the only thing we're not sort of compromised has got to be Intel silicon for us to be involved in. So.
Yeah, and likewise we're agnostic as well. I think all of the manufacturers you mentioned there, we've got relationships with. We've got publicly announced partnerships with Submer, with GRC, and we've obviously got hardware from Isotope here today as well. I think fluids can be optimized for different applications depending on the flow rates, the fluid speeds. I think also if it's natural convection, the lower viscosity fluids definitely have an advantage over the high viscosity.
Yep.
And that's something that we have a core strength in providing lower viscosity fluids than some of our competition. So some of the natural convection tanks, Asperitas, Doug, these tanks would benefit from a lower viscosity fluid. But no, we're agnostic too. And I think just to expand it, most of the hardware manufacturers, yourself, the server manufacturers are also agnostic to fluids as well. So our competitors are also in strong relationships with a lot of the ecosystem as well.
Cool. And one of the biggest topics at the moment is all about sustainability. Now, everybody turns to us as a data center and says, are you sustainable? So that's obviously why we've come around with Atom to actually reuse the waste heat or the thermal energy. I must remember that one, thermal energy reuse. So we do that. Now, one of the biggest questions, and I know I've asked you this before, Alistair, which is greener? Which type of fluid is green? Are plant oils greener than the hydrocarbon ones that originate from the old fossil fuels?
It's a difficult question to answer, Tony. What I would encourage everyone to do is to look at the full life cycle analysis of a fossil-based fluid versus a plant-based fluid, and the cost both of production, extraction, manufacture, and also what could be done in the end case, the end of life case.
Okay.
The degradation rates of these fluids might be different as well. And maybe a shameless plug for the audience would be to look at the Castrol Path 360 piece of work that we're not just showing as a benefit today, but I think in the future it could be a license to operate, and that is looking at collection and reprocessing of some of the fluids that have been already used. And again, next door we've got some of the fluids that have been fresh, they've been used, and they've been reprocessed as well. And if I might, a lot of my work is with the automotive industry, and we've done some of this work with dielectric fluids there. In the Formula E race last year, we supplied fluids to 2 different teams on the grid. They came first and second, incidentally, in the series.
Was that because of your oils?
Yeah. There you go. With some of our gearbox oils. And we collected the gearbox oils midway through the season. We reprocessed them, we put them back into the gearbox, and they continued racing. We didn't need to, and they didn't need to either, but it was more of a marketing demonstration of the art of the possible. And this is going to be very important for suppliers like ourselves, technology partners like Castrol, where fossil fuel and fossil resource extraction is important for a lot of applications in the future, but also reusing the materials that are already extracted are just as important.
That's a good point. I mean, from our perspective, we tend to be fluid agnostic as long as it works within a certain specification. We are interested to look at ester-based oils. I mean, I don't like to use the term oil. I like to use the term coolant, so please forgive me for that. Because when you see the coolants in use, they don't look like oil, they don't behave like oil. They might have a chemical composition of oil, but they look very, very different. And the ability to sort of have the full life cycle control is another big thing. Now, the other piece that I would add to that is that any fluid that is used in an immersion environment needs to show a very strong stability, but degraded where it needs to be able to be degraded, right? And that is a very key point. So you need to, if something is 100% stable, that's a fluorocarbon, and we all know what that can mean. If you were to have something that is that will degrade over time, or degrade under certain conditions that you can incur, such as you could apply a high level of UV radiation. You could apply something else to break down the coolant into its component parts for reuse or remanufacturing. But we would much prefer to consider a solution that the most green solution that we can do, the most sustainable solution, is where you have a lifetime coolant for a particular environment, or be able to clean that coolant during its lifespan if it becomes contaminated. Contamination is not usually due to the fluid. Contamination is usually due to the behaviour of the people who install and put it together, and following good operational practices on cleanliness. That is a really huge deal.
That is a massive deal.
Yeah,
that is a massive deal. Labels.
Oh my lord!
Look,
Labelling.
Labels, servers.
Yeah.
If you ever take a server apart and you lift the lid, just look at how many sticky labels there are on cables, on boards, on processors. Sorry, not on the processors, but on other chips. Great, you can identify them. But one of the biggest problems is the moment you put these servers with these labels into the baths, the warm coolant has an effect on the glue. So all of these labels are really good at floating, which is useless to me as an engineer, because my labels disappeared 3 foot down the bath.
They also have another really bad impact.
That's exactly what I was going to say. And that is true. The bad impact is the glue that's left behind, because that gets...
It's even worse. There's worse than that.
Please do.
So the worst part about it is that the labels will exit the node, but they will not exit the node or the computer equipment in any way that you think is viable. They could sink to the bottom of the tank in a passive configuration. They could float up and then enter your filters, and then they will block your cooling. And therefore you may think you've got an immersion environment, but it's not actually cooling anything. So I can tell you that from our testing, I don't know, I defer to what you've seen from your side, but we would see roughly 35 to 40 days, and then your labels are now part of the coolant. And the glue is part of the coolant. And anything that alters the chemical makeup of that coolant, I would like to think won't affect its dielectric properties, its ability to insulate, act as an insulator, while still conducting heat, so an electrical insulator. But you need to ensure that a good quality coolant will never change its dielectric properties over its lifespan, or under a degree of contamination. You should be able to get something quite contaminated before it would do it. And I'm sure there's some parameters that you would have for your types of coolants that would
and we
affect
didn't speak about the electrical parameters as well, but the resistivity, conductivity, breakdown voltage.
Yep.
They're all slightly different terms, basically about how dielectric a fluid is. The phrase dielectric means that it doesn't conduct electricity. Unfortunately, it's a binary term with lots of non-binary measurements, and almost every fluid's on somewhat of a sliding scale. So when it becomes dielectric, it's a great source of debate in the industry, and that's why you need specifications from certain people to say, yes, it needs to be under this breakdown voltage, or actually above this breakdown voltage, and below this conductivity, etc. And just on your point, my presentation was meant to be about some of the solutions to some of these challenges. You raised a few of them with the thermal interface material. In the automotive industry, again, which is in a lot of materials, are in a lot of components are in contact with oil. There'll be a lot of laser etching, for example, of components. There are other ways to mark your components instead of stickers that could float around, and it's just a mindset shift. Really.
We moved to laser etching.
You have,
and certainly for our processors, boards, and so on. We defer to our ODMs to how they would sort of operate that. But certainly at a processor level, I don't know if you've ever seen a naked processor, you'll see a label, and then you'll see a little weird looking encrypted barcode thing, and then you'll see this other weird looking encrypted barcode thing on the actual substrate material, the green sort of stuff you see on the edge of the proc underneath the IHS. That's where your processor serial number is stored, and then you've got model and batch number details stored in the other one. And it makes it a lot easier, but it's moving to more of a scannable label infrastructure rather than a readable one is something that you can do with laser etching, but it will come down to the manufacturer over time. When you think of the sustainability, can you be more sustainable by not having labels, by not having that glue, by not putting that into your system? Yes, you probably could. But that really will come down to that vendor to do that. In the meantime, we have to have a stopgap solution like our epoxy or some of the spray adhesives I've heard about today as well, spray insulating tools. That may actually also be really, really useful. And I think P-Soup guys have got some great insights. You've been running immersion for quite some time. I think these are the canary in the coal mine people who can really have a talk to these folks, everyone, to see how well something runs over a long period of time.
Yeah. So another one which also comes back in, actually P-Soup might have an input on this one, and I invite any one of you to come and join us.
Yeah, should we get another chair?
You want to get a chair?
Yeah, I was going to say, let's get... One of the weirdest questions is people say to me, is there a difference operationally within the data center between immersion and dry? Have you noticed any differences how you handle the servers, how you deal with them, how you upgrade them?
Mm-hmm. Yep, we do have a big difference between air and liquid and immersion. Just first of all, so the lab operate, just so you understand, is something that we're very active. So Tom and I, we run that facility in Swindon. This is actually Tom's lab. And what the main goal here is that we're able to swap in any different componentry the customer wants to see and offer that to the customer in the configuration that they want. Not necessarily something that we want to, hey, look at this super optimized solution for X. We'll do that if you wish, but our labs pride ourselves on Mr. and Ms. Customer, how would you like to see? I want to see this processor, this memory, this storage, this configuration, this node count, this operating system. We will do that. So that means that we're very, very often opening up platforms and working on them. The most difficult ones to work on are DTC. And the reason DTC is most difficult is because you've got heat sinks that are attached that you have to sort of like lever out of the way and then get a processor out without damaging your substrate pins. And if you talk about 3,000 plus pins, one drop of coolant, one drop of thermal material in that, one misplaced hand, dragging your ID badge across the socket will kill it. So it's very, very important to do that. So operationally, for immersion, it's what we call wet work. And that's where we have a tray. So what we've now learned is solve it with software if you can. If not, remove into a tray, bring it up to your build area, and we have just basically a pair of fans, a pair of high performance 12-volt fans in a piece of foam. I'm really not kidding, okay? We literally just lay that across the node, so the node's sort of laid out on the table laterally like that. Fans on the top, into a power supply, spin that up at full speed, and then I can turn that node on, I can diagnose any memory, I can do everything else. The only thing is, let it dry for 20 minutes, so you're not actually spraying coolant out the side of the node into your build area. But you can work on an immersion node dry to a degree, as long as it's like a sled style node. With DTC is the most difficult. And in fact, we had an issue recently where we had one particular piece of silicon or a platform that we had put in place, and it didn't perform. It couldn't see certain components in the platform. So we actually couldn't diagnose it locally. All we could say is, oh, okay, factory, we've seen X, we can't see device A, B, and C. And they go, right, send it back. So we had to send that back out to the US and have it worked and then come back to us to throw it in. Now, as it sort of turned out, when we got the response back that it was probably our fault for where we integrated a little bit and we put a wrong screw into one slot and it created a bridge. But our US team was very conciliatory and Julie sent it back to us and don't do that silly thing again. But it really illustrated that air, we can work on it locally, diagnose at component level any day of the week. Immersion, you can do the same fairly easily. But just understanding the immersion world, you are working with wet. So it does mean aprons, a bit of PPE. Now, depending on the coolant as well, you may have some specific PPE actions you may take. That'll depend upon whether that be single phase or two phase, direct to chip or an immersion. I'm not going into any specific coolants here, but feel free if I'm talking out of school on your side. So it's just what it really means is that be prepared to diagnose fully if you can before you remove. spend the least time amount out and dry that you need to, recover the coolant that you expose. So if you pull a piece of a device out of a tank into an operations tray, and usually just basically it's a big white sort of tray, that's sort of big, fairly wide lips, fairly heavy production plastic. You'll see one in the immersion hall.
There's two in the hall, isn't there?
There you go. Yeah. So they'll actually, so you throw the things into that, and then you just let it dry for a couple of hours, then work on it. We work on them wet too. We'll pull them out of if we know what the problem is. And the classic one for me is, oh, I've got a bad drive, right? Because we tend to reuse our own storage quite a lot. Format it clean, make sure it's all safe and whatever, but we tend to reuse it quite a lot. So they get installed and deinstalled all the time, and we've had bad ones turn up. Happens to that when you find M.2 SATA and NVMe drives. So over time, you've basically got to pull it and change it. So we're able to do that wet. Just jack out of the tank, lay it across the rest of the nodes, undo the M.2 slot, new drive, shrink back into the tank. We're done in 5-10 minutes. But overall, we've been running for 18 months in immersion in my lab. And over that period of time, we've had racks of systems go in and out of it. We have a very clean floor. We provide a very, very clean health and safety environment. And if we can do it in our world, anyone can, quite frankly. We have extraordinarily strict environmental health and safety in Intel, because the way that our company works is the most restrictive part of the world is what everyone operates on. So there's guaranteed, if I design once, it's deployable anywhere. That's sort of the internal mindset we have. So it's fundamental. As long as we have a good understanding of how to do the job, it's doable. But we've not found any particular thing in immersion, with the exception of one thing, that is a problem. The thing under immersion that is a concern, something that is improving, is the support of fiber. So long-range LR fiber to connect into network interface cards that are submerged can be problematic.
Yeah.
Short range tend to be better. But I don't know, have you found anything on the fibre side?
Well, my talk was meant to be about the hurdles and solutions, and I think we've hit a couple of the hurdles here. Certainly we've spoken about the benefits of immersion, the power, the space, the density, and so on. Yeah. The two hurdles, yes, you mentioned signal integrity, challenges, definitely a lot of work to do, and Lewis that's joined us is going to be hopefully leading some of the charge in that space, getting test rigs, and we've started this already, but we've got resource in to try and drive that forward. And then maintenance, as you've said, maintenance for immersion cooling is more challenging than it is for air, not as challenging it is for DTC, as you mentioned. I'm not an isotope salesman, but there is a slightly different system there where you can use the dry brakes and take it out of the white space, certainly still in the sealed units, and then take it to a different room to open it up. But at our labs, we have much the same systems. Cranes, we would let things drip. We can maybe work on a few things directly. If not, we've got a separate bath where we can collect oil. In terms of the fluid itself, it's obviously designed to be safe. We should always respect the material safety data sheet, the MSDS, which all fluid suppliers should provide you with. But we would also recommend to wear gloves as well. We don't always see people wearing gloves with immersion cooling systems. We would for a couple of reasons. One, it can dry out the hands, and two, there's a lot of oils on our hands itself, and that just contaminates the fluids. Yeah. So we'd always recommend gloves, and if you need some gloves, we can provide them. We've got lots of them at our site.
Yeah, just a standard set of chem gauntlets that you can buy anywhere. If you it really comes down to the SDS, as agreed. But you can usually go down to just standard laboratory style nitriles and things like that are perfectly acceptable.
One thing I will say is when you actually get the tours at lunchtime, or if you're booked on a separate tour independently, ask the questions. It's a fully operational immersion hall. It has cranes, it has gloves, it's even got rubber matting, because trust me, you don't want to spill this stuff.
It's a bit slippy.
It's a bit slippy. But have a look at it. The kit that's required is different to a standard traditional air environment. But look, there's more. We could talk for hours, the three of us, I can guarantee it. What I would say is come and ask us individually. Yeah. But what we'll do is thank you very much for covering this slot. Thanks, I appreciate it. Thanks, so what we'll do is we'll finish up, and I'm going to actually ask Matt from Broadbury to actually come up here and start telling you about servers themselves after we've talked. Thank you.
All right.
Cheers, guys. Thank you.